This is a nice diagram which shows vector u and vector v. We can project u onto the line of v. And imagine that now your eyes is here and you are looking into u directly perpendicular to v. And this point here is the projection of u onto v. To get back u from this point, we need to add wv. So u is equals to projection of u onto v plus wv. We can repeat this for the other way around. We now will project v onto u. So now our eyes is looking at this direction. We are looking perpendicular to u. We look at the tip and we project it onto this point. And this vector here is projection of v onto u. And because there is some residual and we want to complete it, we'll just find v is equals to projection of v onto u plus the residual wu, which is orthogonal to u. In the next slide, we are interested in just finding the norm, which is the length of the projected component. And basically, for this example, if we are interested in just finding the length, all we do is to first find the vector and then take its norm, which will result in a scalar value. Lastly, we examine Pythagoras' theorem, and Pythagoras' theorem says that the length square of the two smaller sides is equals to the length square of the longer side. In this case, it means u square plus v square equals to u plus v square, where in this example, we are saying that u and v's are just numbers, length representing the triangle. Now, Pythagoras' theorem is only valid when we have a right angle triangle. And when we have a right angle triangle, u is orthogonal to v, if we now think of u and v's as vectors. So, why is this true? Well, first remember that u and v are orthogonal to each other. Let us try to find the norm square of u plus v, the longest length. Remember that the norm of a vector u can be found by using u dot u, the dot product of each of himself, square root. Therefore, when we do u, norm of u square, what we are doing is square root of u dot u square. The square root and the square cancels, and we have u dot u. And now we understand why this equation comes about. We are just using u plus v dot u plus v, and then we are finding the norm of u plus v square. We can expand this term and we'll get norm of u square plus norm of v square plus 2 times u dot v. And remember that u dot v is 0 because they are perpendicular. It reduces to norm of u square plus norm of v square is equals to norm of u plus v squared, the Pythagoras theorem. An example is shown on the right hand side. Please try it yourself. And this concludes our discussion of orthogonality and projection for 6.2.2.